Okay, today's lesson notes are on similar polygons. And polygons we just discussed a couple of lessons ago. Any enclosed figure like this, triangle, square, octagon, any of those are called polygons. And so we talked about ratios prior, and now we want to talk about polygons. This is where we use those ratios. All right, a similar polygon is two polygons are similar. This is very important. Two polygons are similar if corresponding angles are congruent. So that's one thing. The corresponding angles are congruent and the corresponding side lengths are proportional. All right, so that's very important to check out. And so what that means is that the angles that match, like angle B and angle E, correspond or coordinate to one another. It's not angle A and angle E. It's angle A and angle D and angle B and angle E. Those angles that actually correspond to one another, they have to be congruent. So B has to be equal or congruent to E, and A has to be congruent to D, and C has to be congruent to F or whatever that is, E, whatever angle that is that got cut off there. So the angles have to be congruent and the side lengths have to be proportional. And so that's important. The sides don't have to be congruent. The angles do. The sides has to be proportional. All right. Now, let's look at an example. All right. In this diagram, triangle ABC is similar. See that one little wavy line? That means similar. If you had two, that means approximate. But that one wavy line means similar. So this is called a similarity statement right here. Triangle ABC is similar to triangle DEF. So they're telling us that at the very beginning, and they want us to list all pairs of congruent angles, check that the ratios of the corresponding sides are equal, and write the ratios of the corresponding side lengths as a statement of proportionality. So, with that being said, let's take a look at it. All right, so if I'm going to take this and list all the pairs of congruent angles, then what I'm going to say is that angle A is congruent to angle B, to D, and angle B is congruent to angle E, and we have angle C congruent to angle, I'm guessing that's F. Force myself to write a forward F. All right, so that's A. That's part A. All right, so now let's look at part B. Check that the ratios of the corresponding side lengths are equal. So the corresponding side lengths will be A, B, and DE. So how about we do 10 over 15? Let's see if that equals BC over EF. So that would be 8 over 12. And again, let's see if that equals AC over DF, which is 12 over 18. And these should all be congruent or equal. The way they look now, they're not. But if we reduce, if we simplify this fraction, this becomes 2/3. If we simplify this fraction, it becomes 2/3. If we simplify this fraction by 6, this becomes 2/3. You see how all the ratios are equal? Now, the corresponding sides mean the sides that coordinate with each other. See, this side AB doesn't coordinate with side DF here. And so you have to make sure the sides are always coordinating. And sometimes they're not always in the same rotation. And so you have to kind of look at it to make sure that the sides are corresponding correctly. We have that's good enough right there. That's all I want to discuss, to show you that this has to happen, that your angles have to be congruent and you have to have the ratios of your sides be congruent. Just for the record, if I did 3 over 2, if I started with the big triangle and did the other triangle, that would be the same thing. All right, let's go back to the notes. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. Okay, the scale factor is simply what the number is that you got. For example, the scale factor on that first example will be 2 to 3, 2/3. All right, so back over here. Determine the polygons if they're similar. So first thing we need to check is, are the angles congruent? That's usually the first thing you should check, because sometimes the answer is no. But as you look, the corresponding angle in A and J are cool. B and K, you see the mark with the same number of lines, so they're telling you all the angles are congruent, so we're okay there. So now what we have to do is check that the corresponding sides are proportional. So that means we're going to do 12 over 21 and 8 over 14 and 8 over 14 and 8 over 14. So we know all those are going to be the same because they're all 8 over 14. But let's reduce anyway. If we reduce this by 3, we're going to get 4 over 7. We reduce these by 2, we're going to get 4 over 7 on every single one of those. So you can say that the polygon A, B, C, D is similar to polygon J, K, L, M. That's a similarity statement. The scale factor, if I can write, the scale factor is, all right, another way to write that is 4 to 7. All right, let's keep going. In the diagram here, they want us to find the value of x. Let's take a look at another way that we use this. We can use this to solve, and this is one of the main things that you're going to do, is solve for variables. And so let's look at this. Put this over here, and move this one over here, so you can see my lovely face. Okay, maybe not. All right. In the diagram, they tell us that these two triangles are similar, so you know that the angles are congruent. We can already assume that. And so we know all three sides here, but we don't know this one. And so knowing that they're similar will help us by using proportions. And so what I'm going to do here is I'm going to say, for example, I need to always include the side that I need. So which one should I use? It don't matter. But how about 12 over 24 equals 13 over x. And see what I did there? I just picked a side. I said 12 over 24 equal 13 over x. I picked a side on both of these that I knew the value for, and I picked the side that corresponded with the side I needed. I could have said 5 over 10 equals 13 over x. Either way. But what you don't want to do is say something like 12 over 24 equals 5 over 10. That doesn't help you solve for x. All right, so you have to decide which ratios to use, and I picked this side and this side to correspond with this side and this side. It doesn't matter. But now we work the problem, we can cross multiply. But I like to reduce first. This is really 1/2. Now when I cross multiply, I don't need a calculator because I didn't know what 13 times 24 was. So that's 26 equals x, which means we found the value of x, just like that. Now, if you just cross multiplied here and divided and everything, you still would have got 26, but it's just easier for me if I do it like that. All right, here's another theorem. You can add up all the perimeters divided by the sum of all the perimeters here, and it'll still equal each individual side, like KL over PQ that corresponds, and LM over QR, and so on and so forth. And so that's just telling you that there's another property here that you can use. And we can maybe look at it like this, in terms of instead of adding everything up all the way, we can say something like, well, let's just look at this example. They tell us that these two triangles are similar, and they want us to find a perimeter of this one. Perimeter means add up all the sides. And so what I would need to do is figure out what xy is and what wy is. You may want to pause right here and see if you can figure this out yourself. But I'm going to go ahead and work this problem out. Alright, so if I take this back over here. No. Alright. Take this back, which now it's not acting right. What I've done here is I said, let me go ahead and set up a couple of proportions. 40 over 72, those two sides correspond. And I use x for this side here, and x over 63 because I don't know what this side is. And then I also said 40 over 72 because all the ratios are going to be congruent based on that last property I showed you. And I call this side y. So 40 over 72 equals y over 81, since all of them will use the same scale factor. So that's where these two come from. I use the same 40 over 72 for different ones because they're all equal. Go back to some of the earlier problems. And so when I look at this, I can reduce these fractions using my handy dandy calculator, because I believe the calculator makes it a lot easier. So this becomes 5/9 equals x over 63. So that's 9x equals 315. So you get x equals 35. Again, you don't have to do this step. You can go straight into cross multiplying if you like to, but it just makes it a little bit easier for me. So in fact, I'm going to go ahead and work this. By the way, that means this side right here is 35. Now, over here, I'll just keep it like this. I'll say 72y without reducing. 72y equals 40 times 81, 3,240. You divide both sides by 72, and you get that y equals 45. So that means this side is 45. By using the same ratio, since we know they're all equal to each other, and I know that by looking at this property here, and really truly by understanding what I had here at the beginning, that they all use the same scale factor. And if you remember the first example that we did, or that you have written down, similar polygons are very easy if you understand ratios and proportions. Okay, a scale factor is that same number that you will get over and over and over. In this case, the scale factor of this last problem that we worked is going to be that reduced 5 over 9. Because each side is going to be 5 over 9 when you reduce it. 40 over 72 is 5/9. 35 over 63 would be 5/9. And 45 over 81 will give you 5/9. And so that will be the scale factor. A similarity statement is this right here, where you use that one wavy line. You're not always going to have triangles. Remember, a polygon is anything. So quadrilateral or any such thing like that. And that's what you're going to have in your assignments. Alrighty. Merry Christmas.